Hey friends, this is Scott, and I've got a word from a new sponsor, and a really cool sponsor, in fact, that I use myself. They are Seek. That's S-E-Q, and you can check them out at getseek.net. That's G-E-T, S-E-Q.net. Seek is the easiest way for your team to capture and search and visualize structured log events. You probably do logging. Maybe you have a Node app or an ASP.NET Core app. Move beyond text files. Check out structured logging. It preserves those individual property values as well as the text that's associated with each event. They get sent across the network to Seek, which then displays them and makes them searchable. It's really easy to get started. You can probably instrument your application if you're already using logging in just minutes. Just go to getseek, that's G-E-T, SEQ.net. You install the Seek server. It's a Windows service. And then it listens and handles all of the logging, whether you're using Node.js and the Bunyan logging library, or maybe you use Serolog on .NET, or just ASP.NET Core's built-in logging. Seek is there for whatever you want to use, whether it be .NET or Node or Python or Java. It's a really great product, and I encourage you to check them out and support them the way that they support us here at Hansel Minutes. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. And today I'm talking with Eric Heutchy. He was a software engineer on the Backward Compat team at Xbox. How are you, sir?
Doing well. How are you?
I'm pretty freaking thrilled because I have a 4K TV that I spent an inordinate amount of money on, and I'm actually getting a lot of really great content on it. It's fun. I thought I was going to have to buy a bunch of new games. And, you know, even though there's a bunch of amazing 4K stuff on Xbox One X, I'm playing all these old games. I played Red Dead Redemption yesterday, and it's like crisper than my memory, which seems impossible to me. And you and your team had something to do with that.
Yeah, it's been really fun. One of the things we kind of talk about is we were able to present the games to you the way you remember them, not the way they actually looked at the time.
You know, and you all did that before with like Halo, right? Like the Halo remasters. But the remasters were people made new textures and like a lot of work went into making it look the way you remember it. But that wasn't the same as the stuff that the Backward Compat team's doing with the what do you call them? The upmasters, the remasters?
Xbox One X enhanced versions of titles.
The enhanced for Xbox One X enhanced. That's different than remastering like we see on other consoles.
It's very different. As you talked about, in a remaster, normally they'll go in and do higher quality versions of textures or models and things like that. And for us, the game is running in the emulator totally unaware that anything has changed. It thinks it's running on a standard Xbox 360.
Really? So this isn't a find the source code and frantically recompile it with new PNGs in a folder somewhere?
Not at all. If we had access to source code, that would be great. Often, you know, we're sitting there looking at a disassembly of code, trying to figure out what's going on.
Mm-hmm. And everyone writes their apps differently, right? Like one or all of these kind of 3D games running, you know, like if I use the example of Red Dead, you know, it's over the shoulder, third person. I'm running around in an open world. There's only so many ways to write that, though, right? There's a mip map, and there's all kinds of textures that people have put together. Those textures aren't going to get any higher quality.
So you end up with, you know, kind of engines. There are different engines that lots of titles use, and so you get similarities there. But there are a number of different engines that were used across the industry.
Mm-hmm.
And so there is a huge variety in how the game actually works under the covers.
I see. So it's not just like, oh, make it work right for Unreal and then everything gets amazing. It is an art form in the sense that each game is being tweaked.
Exactly. And each game will use different rendering techniques and things like that interact differently with the running at the higher resolution.
On all of the forums out there, people are kind of like doing their armchair quarterbacking, trying to figure out how this is done and how, you know, why didn't we ever do it before kind of thing. Is this a breakthrough, or is this something that emulators have been doing, you know, like PS1, PS2 emulators have been doing on Windows machines? And I think there's even some Wii emulators, or is this a new technique?
So there are some emulators I'm aware of that will up-res kind of the final rendering buffer. But along the way on 360, the engines were much more complicated. And you'll get a shadow pass and a blur pass and a bloom pass and all these different passes running. And we've kind of got the ability to tweak which passes run at high resolution and which don't in order to balance out the quality of the final output and performance and produce something that is the game that you remember but looks way better than it did then.
Mm-hmm. And is it really because we just have so much more processing power? It's like, well, why not?
It is actually. This whole thing started out as, we've got something called PIX files, and that is you can take a capture of a game. It takes one frame's capture, and it stores all of the textures, all of the geometry, all the shaders. Everything in that frame gets dumped in this file. And on the compat team, these have been super useful. One, you can look at them and try and figure out where does our rendering differ from what happened on an actual 360. We also have this huge suite of these files that we use for nightly regression. And so every night we've got a whole rack full of consoles that run and take all of these PIX files and play them back. So we got these PIX files, and at one point I just decided, it'd be neat to try and see what happens if we run this at a higher resolution. What does it look like? And, just fooling around in my office, got it up and running, and turns out the games look really, really nice. And this was back prior to Xbox One X dev kits even. And so I got it and then decided, well, this looks really nice. What would it look like in game? And was able to get it up and running in game. And it was beautiful. These games look amazing, but they were running at like 6 to 8 frames a second instead of 30 frames a second. And so it was this really elegant slideshow. And then later when the Xbox One X hardware came out, well, if you look at the performance difference between that and a regular Xbox One, that kind of would get us right to where we would need to be running these at the frame rate we need. And that was kind of, all right, let's see if we can turn this into a real product.
Is the increasing of the resolution easier than doubling of the frame rate? I understand that these games might look amazing, but they are, quote unquote, still or just at 30 frames a second. Would it confuse the game if you suddenly just made them render faster, or is it, is that something that their engines couldn't do even if they wanted to?
Very much that would be a problem. Kind of the game is built around this logic of how quickly am I updating. And there are some games even that have a fixed frame time, and if you play them back too slowly or too fast, time will dilate or expand in the game. And all of a sudden, I'm not holding up frame rate, now the game runs in slow-mo. And so in general, games have many more assumptions built in about what kind of frame rate they run at and how quickly they can update the game world, all the logic, run AI, run collisions, that type of stuff. Whereas graphics, we've emulated the Xbox 360 chip, the GPU in there. And it's possible for us to say, well, we know when we're rendering, when we do that, we're going to increase pixel count here. And as I said before, without the game even being aware of it.
So when I play like Red Dead Redemption as an example, but we'll use it as a generic example, the dude that is running around is amazing. The signs in the distance are amazing, but like the HUD, generically the heads-up display, looks the same because I guess no one ever did a high-res HUD. And why would they even imagine that?
Exactly. There was no reason to put a high-res HUD in because it was always shown at some set number of pixels, and so they probably designed the art to be exactly that number of pixels.
But how does it not show up in like the upper left corner? Like why does it show up correctly positioned relative to the rest of the screen if it's running at a high resolution?
So that's part of the technique here, is just making sure that the viewport, that things are positioned in the same place on screen rather than being offset at a specific number of pixels. And so if in the game it originally was offset a specific number of pixels, well, now we scale that up by whatever factor. We've increased the resolution.
I see. Does it help that 4K is exactly for 1080p screens, or is that an overly simplistic benefit at all?
So the way we actually work is most of the Xbox 360 games ran at 720p or something similar to that.
Oh, wow.
And so we'll up the pixel count by 9x, 3 in horizontal, 3 in vertical. And so if the game was 720p on 360, we run at exactly 4K resolution. A lot of games ran at something slightly below 720p, and then we run at the same ratio below 4K.
Oh, I get it. So this is not just 4x. This is huge. This is almost an order of magnitude clearer, which apparently in my memory is also apparently an order of magnitude clearer because it does feel both simultaneously amazing. And you really, to be clear, we're talking about this in a podcast, so the irony is not lost on me. But people who are listening need to find a friend, go and see an Xbox One X on a proper 4K machine, and you will be blown away that you are playing a 360 game. It is almost impossible to get your head around. But it's also simultaneously exactly how I remember it.
It is, and it's amazing how well some of these games hold up, and quote unquote, all we're doing is increasing the resolution, but the assets in there, the textures were way beyond what the hardware at the time was able to display. And so now we've got more powerful hardware. Let's take advantage of that. And, these games look gorgeous.
So using Red Dead as an example, as I walk up to a building, there might be a wanted sign on the wall. And this is now getting into kind of the mind of the Redditor. Well, I guess they're just using the close-up texture all the time, like the texture that you would see. And we would do this. We've all done this when we had an original Xbox or an Xbox 360 to get a feeling that it was super high res. That you'd walk right up to someone's face, like we all played Half-Life, right? Mm-hmm. You walk right up to the bad guy's face just to see how good the textures are. But then you back up and then they get blurry. Are you doing everything at high res, or are you doing it adaptively so it feels like it's always high?
So the fun thing here is we're not explicitly doing anything to show a higher or lower quality version of the texture. The way the graphics chip works is you've got bitmaps, so you've got the highest resolution version of the texture, and then you have another version that's a quarter the size of that, and another that's the quarter the size, all the way down till you get to a 1x1 pixel. Here's what this would look like from really far away. And then as it's rendering, the GPU will say, how close together are these pixels that I'm drawing? If they're really close together in the texture, then you use a highly detailed version of the bitmap. Whereas if you back away, well, now the pixels may be farther apart in the texture, and so it'll drop down to a lower quality MIP. And so what we've done is increase the resolution by 9x. That means that whereas before it would be, drop down to the second or third bitmap, now it can be up at the very top level and giving you that highest quality thing that was already there in memory, but the hardware before was limited and just didn't have enough pixels to show you it.
Okay, I got you now. And again, without anyone being the wiser, like there is a virtual 360 in your Xbox One X with a high-res card, but it just doesn't know.
Right, that wanted poster exists in 8 different versions, let's say. And on the 360...
And always did, even did in the old days.
And on the 360, when you walked up super close, it was able to use that highest quality one. And then when you backed away a little bit, it dropped down. Whereas in this Xbox One X enhanced version, as you back away, we're able to keep using that high quality one for much longer because the pixel density is so much higher.
Mm-hmm. What about games that did dynamic resolutions and adaptive resolutions? I don't know of any specific ones because it all looks amazing to me. But there are games that are like frame locked and resolution locked, and then there are games where they'll talk, like Halo will switch the resolution down a smidge, and then it'll all happens frame by frame.
Yeah. So on Xbox One, that's gotten to be a really popular technique. I'm not aware of anything that used it back in the 360 generation. There may be something.
Okay.
But in terms of frame rate lock, you'll often see games that it's less of a lock and more of they're just certain scenes in games that don't keep up with the intended frame rate and it'll slow down. And, very often in the emulator, we're able to maintain a higher frame rate through certain scenes than the original hardware could.
Yeah, okay. So why are people minimizing this so much? Like you're saying that this requires, you're saying in a very simple way, like, oh, that's how it's done. But it's more than just, otherwise it would have been done years ago, right?
I think it's one of these things of the Xbox 360 generation was one of the first times when you had that much texture detail and that much geometry that, developers really had built this much visual fidelity into their game that wasn't able to shine through.
Oh.
And also, just in terms of engine complexity, things got much more complex. We've also done some original Xbox games via compatibility, and they upscale both on a regular Xbox One at 4x pixel count and an Xbox One X at 16x pixel count. And you can see there, it was starting to be the quality of texture and the quality of geometry. Those games hold up beautifully as well, too.
Yeah, I was playing Ninja Gaiden. I think it was Ninja Gaiden Black on my Xbox One X. And that game is, a while back, but it had, I think it was 2000 and early 2000s, 2005. This is a 12.
Yeah, 2004, 2005, something like that.
But it was a 16. It was one of the few 16 by 9s, as I recall. You can go and buy it even now, I think for like $5 or $10. Mm-hmm. Yeah, $10. At least 10 years ago, and it does hold up. If you're sitting in a norm, if you look at it real close, you can tell, but it moves. It's really interesting. The resolution and the graphics aren't what makes it feel even a little bit dated. It's the camera control. Like, we hadn't decided yet as an industry on two-thumb camera control.
It's fascinating to see games that are this old, and I played that game back when it came out, and be able to play it now and see what it looked like then versus what it looks like now, and how well the developer's vision is coming through there. It's just really exciting to be a part of.
It's exactly what they, not just what it's the way I remembered, it's the way they always wanted it.
Mm-hmm.
Yeah. And it also, even though you work on the back compat team and we're talking about the graphics aspect of things, it's worth pointing out that, like, I just fired up a couple of hours ago, what's it called? Tom Clancy's Splinter Cell Conviction. And I loaded up a save game from 6 years ago that I'd totally forgotten about and ended up, finishing the game. And I've gone from an Xbox One to an Xbox One S to an Xbox One X from an original Xbox 360. So that's 4 consoles from Red Dead Redemption. And I've been on the same, on the same save game for so long. It's just cool. I don't think people get the respect they deserve for the organizational willpower that Xbox gives us, backwards compatibility across everything, not just making it pretty, but making it functional.
It's really cool to be able to light up the scenario where, as you said, you keep your save game that you had from 10 years ago. Mm-hmm. And similarly, all these games that you bought digitally, and just one day, hey, it shows up in your ready to install list of, we've got a new game ready for compat, and this game that you played back then, go at it again.
Yeah, it's funny that you mentioned that, the idea that I don't even remember when I bought that digitally, and then suddenly, Knights of the Old Republic is available again. It's like, oh, I guess I can install that and play that. And more importantly, introduce it to my kids and not have them tease me because that movie's black and white, Daddy.
Exactly. I've been playing Fusion Frenzy with my kids, and Knights of the Old Republic, I'm working through it with my son because he's a huge Star Wars fan. And it's really cool to have this experience that, I have great memories of the game. And you talk about movies not being black and white. Mm-hmm. Video games are this interesting thing of, it's kind of historically been you play a generation and then that's it, it's over, and it's kind of hard to play those games anymore. But a great video game is going to be a great video game 10, 20, 30 years from now. And being able to preserve my collection of games and those memories and relive them with my kids, same thing I would do with a movie. It's really nice being a part of that.
As a consumer, I hope, I don't have any inside baseball, but I hope that this is kind of the end of the console generation every certain number of years. And if the entire Xbox, game library can be brought forward forever, then, like you say, 20 years from now, we'll still be playing games across multiple generations on a single piece of hardware, which will be pretty exciting. Hey folks, Intel is a sponsor this week, and I welcome them because they're bringing some high-performance developer tools for all of us. Check out Intel's Parallel Studio XE. I've talked about parallelism before on the show and the importance of using the complete instruction set, unlocking the power of the processor that your code is running on. Now, you all might be writing C or C++, Python, or even Fortran, but is your code building in such a way and written in such a way that it uses the latest techniques for vectorization, multi-threading, multi-node parallelization, or memory optimization? Intel Parallel Studio XE has a lot of new stuff for 2018 across all these languages. Get a free download at bit.ly/parallelstudioxe, or certainly go and Google with Bing for Intel Parallel Studio XE, and get started boosting your app's performance with smart, parallel code with a lot less effort. Check them out, bit.ly/parallelstudioxe. So MIP maps, back to the tech. MIP maps, that's level of detail, right? That's the image quality. They were also originally done to reduce stress on the GPU and the CPU because of that back off. How do you use the same kind of techniques to keep the processor working, but not working so hard that you're going to lose frames?
So we don't particularly in terms of MIP maps, like you get the benefit of less memory consumption when things are far away and you're using lower level MIPs. But for us, a lot of the cost is we're running an emulator. And so the normal kind of emulator thing of in order to maintain accuracy, you end up doing, instead of a simple single operation, maybe you have to do a few things. One thing that pops to mind is when they were emulating the original Xbox on the Xbox 360, and they had to do a floating point divide. And it turned out that the original Xbox had a slightly more accurate divide in certain cases, And so in the emulator, what they would do is do the divide and then do a Newton-Raphson iteration to refine the result and be able to match bit for bit what the original console produced. And so just in general with emulators, you end up doing all these weird things of, well, in the case of NANDs or, certain denormal values, the result's different. So we have to do these expensive tests to make sure that we get bit accurate results there. Similar kind of thing in the emulator is that our shaders end up being way more complicated than they would normally be because we have to handle some of those weird edge cases. Or, certain pieces of hardware, there are certain techniques on 360 that were extremely fast. And in emulating them, they end up consuming huge percentage of our frame time. And so there's kind of,
Really?
If we could just run the same code, yeah, it'd be trivial to run this thing at whatever frame rate we wanted. But to be able to run it emulated so it's running the same way it did on a physical 360, we end up kind of having to try sometimes various tricks to make some of these things that end up being much more expensive under an emulator. Where can we reduce those, turn some of those things off?
And the Xbox 360 was a IBM PowerPC based thing, right?
Yes.
And what is the Xbox One X?
The Xbox One X is x64.
Oh, okay. So you are literally running a PowerPC emulator and emulating the original GPU, and then assume any of the weirdnesses of all those things.
Yeah.
And if it did something even remotely wrong, you also have to be wrong on purpose.
Exactly. And it may be nobody ever intentionally assumed that wrong thing would happen, but some game accidentally used it and took a dependency on it. And so even if something was a mistake, well, we've got to be able to faithfully emulate it because some game's going to do it.
Right. Taking a bug as a dependency.
Exactly. Oftentimes we'll say, there's no way anyone ever did that. And then without fail, 2 months later or 6 months later, we find, nope, here's the title that did that.
Right. And then also we have to remember that there's an Xbox One, an Xbox One S, and an X, and you've got to make it scale up appropriately as it moves through these kind of 3 sub-generations of Xbox Ones?
We do. And in terms of the development side, for a game that we're not doing an Xbox One X enhancement for, we kind of just ship it as is, and it will generally run fine. Now, our test team has to go through and make sure that running it faster on the Xbox One X doesn't cause problems. But that's something that we really haven't seen outside of maybe a couple isolated cases.
And does this mean that people have to play the whole game?
So
like someone's literally like, oh man, I got to go through The Witcher again.
We have an army of testers, and they will go through and kind of games go through these different phases of, well, we've ingested the binary and now we can make an emulated version of it. And then we run it for a while and capture some data about it. And then we have what we think is a shippable build. And then we have them play through the entire game, start to finish, kind of trying to find every corner and make sure everything works. And now they do that both on a Xbox One and a Xbox One X. And then as we get closer, there's some more checks before we ship. But there are a large number of people whose job is to play through these games over and over.
Oh my goodness. Now, there's also something I noticed that surprised me. If ordinarily there's the Xbox guide button, that big kind of bright button in the middle of your controller, and you push it and it takes you home. On an Xbox 360, it would bring up the Xbox 360 guide. The way that you get to the guide on Xbox One X, if you want to get into the Xbox 360 guide, is kind of a punch through. You push start and select or view and menu simultaneously, and you get into, is it a real Xbox guide or an emulated one?
It's running the emulator still, and at that point it's just emulating what would happen on a 360 in terms of bringing up the guide.
Right, but it has a special menu that says Xbox One X settings, which kind of increases the inception of it all, because you're finding a setting within the emulator that refers back to the host. It's almost like finding a VM-specific setting. And it has a choice between graphics or performance.
Mm-hmm. And it was kind of fun to put that into the guide there, because that's probably the last button that will ever be added on an Xbox 360. And what is it? Now it's a reference to this console that's came out 15 years after the first one, or 10 years, or whatever it is.
Why would I ever not want to optimize the game for graphics?
If you wanted to see what it looked like originally, one thing we've seen a lot of people do is record comparisons of the graphics mode versus the performance mode. The other reason it's in there is if there's a case where we aren't able to maintain frame rate while running at the 9X enhanced version, you could run at a higher frame rate potentially. Across all the games we've shipped, there are basically no instances. I think there may be 1 or 2 corner cases where we don't quite hold the frame rate running in the enhanced mode. But in terms of if you just want to enjoy the game, we're very careful to make sure that if we're shipping an enhanced version, it keeps its frame rate, and graphics mode is what you should be playing in.
This is amazing. So full frame rate that you expect at 9x the pixel count, and virtually no games that you've seen that have that can't hit that full rate. I've never seen a slowdown on any of my emulated games.
Yeah, the army of testers has found one or two scenes where you look a certain direction and it slows down, but just playing through the game,
I see.
You're unlikely to find that.
Okay, so. What about bugs, right? This can't just be, the story that you told. Oh yeah, we figured this out, and I guess it looks amazing, and it has so much power. Like, of course it looks amazing. There must be this game or that game had a weird way to think about stuff or bugs that got you unexpected results when you started throwing high-res textures and different aliases, anti-aliasing settings at them.
There've been all sorts of bugs that come through this. One of the more interesting ones was there's something you can do called a visibility query, which is basically a way for the game to say, I want to know how many pixels actually get drawn by this draw. And so the game will draw some stuff, and then it will, draw something under a visibility query and use that later on the CPU or on a future GPU call to make a decision. And there was a game where I think it was an extra flashlight got turned on, couldn't figure out what it was, and eventually tracked it down to the visibility query was now saying there were 9 times the number of pixels visible that there had been before. And the CPU was doing some calculation and saying, oh, that's a bunch of stuff. I guess it was a light beam, a glow from a light source. And so it was saying, well, that looks like a lot of pixels were visible from this light source, even though it was barely visible. But since we'd scaled up the visibility query, the CPU said, that's visible enough. I need to show this glow. And so this really awkward glow showed through, and we had to go through and say, nope, when you're doing a visibility query, cut that down by the appropriate ratio.
In the Windows world, I know that there's all kinds of backwards compatibility kind of catalogs. So and I'm just picking a name, I don't know this to be true, I'm just picking it. Like, let's say QuickBooks acts weird on Windows 8 instead of Windows 7. There's a whole team at Microsoft that says, oh, look, they called get hwind in a weird way. They're expecting a certain thing. So then they don't actually patch QuickBooks, and they don't really patch Windows. They just kind of like promise to lie, or they patch that one function call as a way of saying, yeah, when QuickBooks does it, it's different. We'll give them something special. And this is part of Windows' larger dedication to things just working, right? How are you patching without patching in the way that you're describing?
So in terms of things patched like that, I think more on the CPU side, where, for instance, we've had games that were originally multiple disks. And so you play through your game, and at some point it pops up a dialog that says, please insert disk 2 now. And we'll have people go,
yes.
So now we want to ship it digitally, and there's not another disk to put in. And so the devs will go through and figure out where was that API call and stub that out from the game. So instead of popping up this dialogue, you just keep playing through. I'm trying to think if there are any GPU cases that are similar to that. A lot of it is just in the scaled world, make sure we're lying appropriately so the game isn't able to realize that the pixel counts are different than what it expected.
Mm-hmm. Is it kind of a bit of state management? You have to keep in mind, how long have we been lying? Have we been lying inconsistently? Are any of our lies going to come back on us when they get to the end of this level?
Yep. Usually we just have to worry about within one frame. Occasionally things persist beyond that. But sometimes it's even this, we'll keep a copy of our super fancy high-res version, but we'll also make a low-res version because the CPU is going to access it or something else is going to access it and need that lower quality version for whatever reason.
Oh, wow. That just blew my mind. So what you show the user, which looks amazing, may not necessarily be what you told the CPU that we showed the user. And you say, hey, here's the low-res version. Here's the non-retina display. You go ahead and look at that, and it's the same. Don't worry.
Exactly.
And as long as you're lying consistently, it's
keep
fine.
Up that illusion that, hey, game, you're just running on a normal Xbox 360. Everything you expect to be there will be there.
Mm-hmm. It feels like the backward compatibility library, and again, I'm speaking as a user, started slow. You heard nothing but complaints about like, well, what about this and what about that? And now it's coming faster and faster and faster and faster. Is it because you all have built up a library of tricks and tips and ways, like you've polished the way you do back compat? So now you can start not just releasing back compat, but also Xbox One enhanced back compat.
Yeah, I think a lot of it just comes with the maturity of the emulator and the optimization time that's been put in. Back when we launched, we had some games that we wanted to ship that we just couldn't get to run at frame rate. We had games that instead of at 30, they would run at 10 or 15 frames a second. And we don't want to ship this poor experience. So at the time we said, here's a title we don't think we're ever going to be able to ship. And then over the next year or two, as we put out more titles, we'd optimize various things and make bug fixes in the emulator. And the technology has matured and matured. And then we came back and said, hey, this game that we didn't ever think we'd be able to ship, if you play it now, it's holding 30 most of the time. And we're able to go back to it and able to ship it. And so there have been titles we didn't think we'd be able to ship. And as of right now, been able to ship one, the first one that ever stuck out as this might not be possible in the emulator. And so that was a really, really cool feeling.
Yeah. I'm actually going and buying a bunch of these games that, like, for cheap. Like, you can buy the original Assassin's Creed, which was gorgeous at the time. And it's even more gorgeous now. And it's like $15, $10, $20,
And then it's this thing of a great game is still a great game, whether it came out 10 years ago or came out this week.
Absolutely. I just bought and finished from an old save game, Splinter Cell, simply because I saw that, like, I've been finally waiting for this, and it's backward compat. And I went on Amazon, and I think I got it for $5 and got it immediately. And I'm looking forward to getting back into Crackdown. I know I have a save game in Crackdown going back a while, and I never made it through Witcher 2, which is now back compat and enhanced as well.
Yeah.
Last question I have is, why is it called the Heutchy method if there's a whole team?
It got named after me because I was kind of the dev that experimented with it and got the technology up and running. The GPU team is relatively small. There's about 5 of us or so, but I've definitely had help as we've been getting these games enhanced. So despite having my name on it, it's been a team effort.
Do you feel weird having, like, I assume you see the Reddit threads and the forum threads, like, oh, the Heutchy method, it's a method, like it's capital H, capital M, like, it's a method.
The weirdest thing for me is seeing my name spelled correctly and having people pronounce it correctly, because all throughout my life, it's been a strange name and people struggle with that. And so that's been,
Not anymore. You've got the juice. Like, you get auto completed when people type your name now, which is pretty sweet. Well, thanks so much for chatting with me today.
It's been a pleasure. Thanks for having me on.
I would really, really, really encourage folks that have Xbox and that have an Xbox One X, or if you have a friend, check this out. The backwards compat is such a joy. It really cannot be overstated. I know I sound like a fanboy, but it has really opened up my whole library and brought me back to a bunch of games that I'm just happy that I've been able to play them again. This has been another episode of Hansel Minutes, and we'll see you again next week.